Midnight. You're exhausted. You promised you'd eat better today, but here you are, reaching for the leftover cake in the back of the fridge. We usually categorize this moment as a character flaw. We assume giving in to a late-night sugar craving is a simple failure of discipline, a sign that we lack sufficient self-control. But neuroscience paints a very different picture. When you stare into that fridge, you aren't making a conscious choice. Your brain is caught in a fierce biological war between two entirely different neurological systems. First, there is the top-down system. This is where your willpower, logic, and long-term planning live, housed right behind your forehead in the highly evolved but incredibly fragile prefrontal cortex. Then there is the bottom-up system. Deep in the basal ganglia, it controls your survival drive and response to immediate energy demands. When tired or stressed, these systems clash. The bottom-up system is hardwired to win, overriding your prefrontal cortex to secure fast calories. A sugar craving represents a physiological hijacking of your brain's survival mechanics, operating entirely outside the realm of moral discipline. The hijacking starts the moment sugar hits your tongue. Sweet taste receptors fire massive electrical signals, traveling straight up the brainstem and into the cerebral cortex. This pathway floods your reward centers with dopamine. It answers a single subconscious question your brain is constantly asking: should I do that again? When it comes to sugar, the answer is a resounding yes. This graph tracks your brain's dopamine response to different foods. If you eat a plate of broccoli, the dopamine curve naturally spikes and then flattens out. The brain evolved to get bored of the same healthy foods to encourage seeking a variety of nutrients. Sugar is a rare exception. The dopamine response does not level out. Because it continues to feel rewarding every single time, sugar behaves similarly to an addictive drug in the reward system. Your basal ganglia takes this continuous dopamine flood and builds a highly efficient, automated habit loop. You feel stressed, you eat a sweet, you get a chemical reward. Cue, routine, reward. As early psychologist William James observed, repeating actions in similar circumstances eventually ingrains that behavior into our brain circuitry until it runs on autopilot. You aren't weak. Your brain has simply been successfully and efficiently programmed to seek a highly specific chemical reward. This programming is amplified by physiological deficits, starting with sleep deprivation. A lack of rest actively hinders the logical, top-down brain. Every hour you stay awake, a waste product called adenosine builds up in your brain. Too much adenosine directly impairs the prefrontal cortex, effectively muting the very circuitry you rely on to manage impulses. Pushing the brain into extreme sleep deprivation carries severe neurological consequences. In extreme cases, like a devoted fan staying awake for 48 hours straight to watch the World Cup, the accumulated strain can trigger a fatal stroke. On a daily level, this exhaustion causes a hormonal shift. Poor sleep spikes ghrelin, the hunger hormone, tricking your brain into believing it is starving and desperately needs quick, calorie-dense energy. Then comes the second saboteur, chronic stress. Constant anxiety floods your body with cortisol, depleting your systemic energy and forcing your brain's affective pathways to seek out immediate emotional comfort. Stress and sleep deprivation act as heavy weights on the bottom-up side of the scale. This imbalance ensures the survival drive stays in control, while logical willpower signals are drowned out. The final piece of this trap is how your body processes fuel. A constant intake of processed food traps many people in a rigid carbohydrate-burning state, stripping away the body's ability to switch to burning stored fats. Look at this area chart tracking blood glucose levels. Instead of smoothly switching fuel sources, the body rides a metabolic roller coaster. Unnatural spikes in blood sugar from sweet foods are suppressed by an aggressive rush of insulin. This rapid drop in blood sugar acts as a severe biological panic signal. Your cells detect a sudden energy deficit and sound an emergency alarm across your entire nervous system. This metabolic crash completely bypasses rational thought. Your body isn't politely asking for fuel. It is demanding immediate, easily digestible calories simply to survive what it perceives as an acute crisis. Evening cravings are the inevitable biological math of an energy-depleted, metabolically inflexible system crashing at the exact moment your day ends. Attempting to beat a bottom-up biological alarm with top-down willpower is rarely effective. You cannot simply think your way out of a chemical deficit. To disrupt the cycle, you have to use a bottom-up approach. This involves updating the reward value in your brain, letting your system discover through direct experience that the habit isn't as rewarding as it thinks. This starts with physical interventions. Securing deep, quality sleep lowers your ghrelin levels, while managing stress halts the cortisol spikes that trigger emotional eating pathways. This diagram illustrates metabolic adaptation. Hormones like FGF21 signal fat tissue to burn calories, while nutrient sensors restart autophagy to recycle damaged proteins. Mitochondria regain the ability to switch fuel sources, providing your brain steady energy and preventing blood sugar panic. Replacing the willpower myth with an understanding of these internal systems changes the goal from fighting a moral battle to managing a biological system. When your physiology is aligned, the craving loop naturally loses its power.